Hello everyone, welcome to IoT Frontier. My name is Hariharnath. In this video, let's look into one of the end-to-end solution using Azure IoT. So in this project, we'll be learning how to send an email alert whenever you detect high temperatures using sensors. So we'll be using DHT11 sensor connected with Raspberry Pi and send the data to Azure IoT Hub. So stay tuned until the end of this video to get all the steps right. Before we get started, if you haven't subscribed to the channel yet, please subscribe and hit the bell icon. Let's get started. So as usual, let's look into the GitHub for the steps. As we are running the code in Python, so Raspberry Pi needs Python version, and also there are few prerequisites in Azure. The first one is we need to create IoT Hub and IoT Hub device. So if you haven't watched my previous video, you can watch my previous video on top right corner so that you can get how to create IoT Hub and IoT Hub device. Next thing is we need to connect to Raspberry Pi and check if the Python 3 version is not there or available. So I'll use PuTTY to connect to Raspberry Pi. So Python version is available. If it is not there, you have to use these sudo commands for installing the Python 3. And there are some required packages. For example, Azure IoT Device SDK and Async.io package. So those are also present in my system, so I'm not running those. And also, as we are running the DHT11 sensor, it needs some library. So we have to download this library and extract it and install it. Now let's look into the components that are required. The components that are required are a Raspberry Pi, the micro SD card with Raspberry Pi OS, and then DHT11 sensors, some jumper wires, breadboard, and then power supply. So last time we have discussed DHT11 sensor in another video. So we are going to repeat the connection for those here also. For the 3-pin, we are going to connect with the Raspberry Pi board. And for the 4th pin, we use one pull-up resistor and to connect it. So here you can see I have connected the first pin is signal and positive negative. So signal pin is connected to this GPIO pin as per the schematic, and the positive is given to this and the negative here. So you can follow the schematic and connect it. And the workflow of this project is going to be like this. So we'll be having Raspberry Pi here, and for that DHT11 sensor is going to send the temperature values, and then in here we'll be having monitoring the temperature values. If it is high, then immediately we send an additional property to Azure IoT Hub. So Azure IoT Hub receives that and sends to the Logic app, and Logic app will trigger the email to your email address so that you will be notified about there is some high temperature alerts so that you can act upon it. So next step is we need to look into the code and save it on the Raspberry Pi. So I'll explain what is the code that we have written. So this code is already almost same as the previous video that we have worked on DHT11. The only difference I will try to explain. So here in the main code, we'll be having device client from the connection string. So we'll be having Azure device client, and then we'll be running the loop to get the telemetry values. So once we go to this function, send telemetry, so here we'll be having the device client being connected, and then we have the library as we have discussed. This is the Adafruit library from which we read the humidity and temperature, and we will format it in such a format so that it will be used in Azure IoT Hub. And once we format that, it will be encoded with UTF-8, and the content type will be JSON. And additional thing that last time we haven't used in another tutorial is this custom property. So I have put a threshold, like if the temperature value is greater than 30, then there should be high temperature alert for the sake of this tutorial. So basically in reality, it may not be just 30 degrees. So it can be more than that. So to make easy for this tutorial, I've used this. So this is the additional custom property that is going to be useful for triggering our alerts. And then it will be sending the messages to Azure IoT Hub. So now as I have this code in my Raspberry Pi. So here I can see my code is under this send DHT11 Azure IoT Pi custom property. So I have already saved it. If you haven't got this code, you can download from this repository and save it to that. So next is obtaining the device connection string. So we need to go to Azure IoT Hub. So as I said, we need to have this previously, and I have given the link in the description. So go to IoT devices. So under our devices, we have to copy this primary connection string and use it in our code. So in my code, I have already pasted the connection string. So you can replace the default one into this connection string here and save it. So once you are done that, you have to go to Azure and complete the remaining steps. The first, we have to create a service bus namespace. Because if you see the workflow, IoT Hub has to send the data to Logic App. So directly we cannot connect Logic App with IoT Hub. So we need in between some service bus like service which can handle the messaging. So that's why we create first a service bus queue and then send the data from IoT Hub to service bus queue, and Logic App can receive based on the trigger. So first we'll go to service bus. So we have to search for service bus, or if it is there, you can click on service bus here and click on create. So you have to first create the namespace of the service bus. Select the subscription and create a new resource group. I'll be using a resource group for all of them as Logic App. And the namespace, I'll use IoT Frontier SB, or I can use SB-IoT Frontier. Yes, it is available, and the pricing tier I can use basic. Just for this tutorial, it is enough. And TLS everything as it is. So validation is successful and I have created. So the deployment is complete and we can go to the resource. So we have this service bus namespace first. So we have to create a queue in it. So go to entities queue and create a queue. So you can give it a name as SBQ IoT Frontier. So remaining everything, I can keep it as it is and create. So this queue has been created. Now let's go to the step here. So we have seen service bus namespace is created, service bus queue also created. Now we have to create a custom endpoint and routing rule to our IoT Hub. So we need to go to IoT Hub that we have already. So go to this IoT Hub, we have to go to the message routing. So by default, you'll be having events. So this is going to be sending the messages to the built-in endpoint, that is Event Hub. So here you can see that I'm using free tier IoT Hub. So that's why only one endpoint can be created. So I'll have to delete the existing one and then create a new one. So we'll create a new message routing. So here we have to select the service bus queue, and here endpoint name, we have to select an existing service bus endpoint if it is already there. So I've already created this. If you not, you can create and select it and then click on next. So we have to give a route name. So route can be SB route. So service bus route. So we have to enable this and then give the temperature alert is equal to true. So this is what we have to give the routing query. So based on our messages that we are sending from Raspberry Pi, these will be filtered with this temperature alert and see. So we can cross compare this here. So we can see temperature alert, and you can also directly paste it here and give true. Whenever this is true, then only we'll be having the messages gone to service bus. We have to use true as string. So once we have done that, we can click create. Yeah, so the message routing has been created. Now we can look into the next step. So routing rule of the custom endpoint is done, and we have to create and configure a logic app. So logic app is another service by which we can trigger based on whatever we have given some condition, and based on that condition there will be a trigger, and so based on that we can perform some action. For example, in this tutorial what we are going to do is the messages that are coming from IoT Hub we are sending to service bus. Whenever a service bus receives a message, that message will trigger an action in the logic app. So for that, we have to configure the logic app. So the creation of workflows can be done in logic app. So now let's go to logic app and create let's add. So we'll have to create. So I'll use the logic app RG, that is resource group, and then I'll use LA IoT Frontier, and I can use the workflow as it is. And the East US, I can use the consumption based because standard will be using more credits. So, and as I'm using just for entry level programming in this tutorial, I'll use only consumption based plan. So this consumption based will only pay whenever you are running the workflow. So for the remaining time, you are not going to pay. So zone redundancy is not required for this tutorial. You can click on next and create. Yeah, so the deployment of this logic app is done. So inside the logic app, we have this logic app designer. So you need to go to that and click on blank logic app. So here we'll first have to get the connector for service bus, because we have to connect with service bus and get the trigger as whenever any messages comes, and then perform an action of email. So I'll just search for service bus. So I'll be able to see the service bus service as a connector available here, and I'll select that. So in that we'll be having so many triggers. So one of the trigger that is whenever a message is received in a topic queue. So because we are not using topic, we are using queue. So we can see this autocomplete. So whenever a message is received in a queue, I can perform some action. So I'll use this trigger. So while using, it will ask for some connection, and it will be using access key. So I need to provide the access key of the service bus. I'll go to service bus. Inside the service bus, I'll go to shared access policy and copy this connection string. And provide here. So now we'll be able to see our name of the queue populated. And here I can select based on the, like how often do we want to check for items, new messages coming. I just want to keep it less than 1 minute. So for this, I can keep it 1 minute as well. And then the next step is we got the trigger right. So next we have to do the action. So plus news tab. And here we have to search for Outlook. So I'll be using Office 365 Outlook. So I tried this in incognito and it was not working. So you have to use it in general browser without incognito mode. And I'll search for send action. So send an email action is there. I'll select that. So now we have to, so now we can see that we have to create a connection so that we can log in as a Outlook system in it and then send a message mail to anyone. So first I need to sign in. So I'll sign in with my account. So if it is successfully signed in, you should see other fields available here. So we can see that to, subject and body, everything is available. So I can use to one of my mail. So this is my mail, and then I'll select the subject. So high temperature alert. And in the body, I can also mention that as short, I can use high temperature alert. And if there is some dynamic content, like what is the complete message we want to send, we can use this service bus message. So it will give you complete message. But we can also take the message and pass it so that we can only get the temperature value, but I'm not going to do right now. So I'll just use that. So we complete service bus message, and then I can use this save message. So once we save this logic app is complete. Now let's go to another step. So now we have this logic app trigger and logic app action configured. We have to test the logic app and then we have to run the code. So running the code as usual, we can use the code available. Now I can see the message is being sent every 10 seconds. I can also check the service bus if the messages are coming or not. So if I can go to queues, and under the queues, you will be having Service Bus Explorer. So in that, you will be seeing an option called queue. So inside that queue, you can refresh and see the messages. So here we cannot see messages in Service Bus. It is because the temperature is not crossing 30, and we have kept a condition that if it is greater than 30 and the temperature alert is true, then only it will go via that route. So, and we have enabled the default routing as well in Azure IoT Hub. So you can see the routing has a fallback mechanism. So it is asking us to disable, which means that it is already enabled. So I can go to IoT Explorer and look for the messages. So it will go to default built-in event hub endpoint. So I can go to our hub and the device, go to telemetry and start listening. So here we should be able to see the messages that are being sent. So one message has been sent and immediately we have received it here. So if you want to send it to service bus, then you have to increase the temperature. Now we can see the temperature as 27 degrees. So we have to increase the temperature to more than 30. So I'm using hot water for that. So I'll place the sensor on top of hot water. So the fumes will try to increase the temperature of the sensor. So now you can see the temperature value is going more than 31. And now here we are seeing messages continuously. So we can see the high temperature alert message already coming. So we can see high temperature alert and the complete data, in which we can even see the temperature values as well as the device information, etc. So we can see continuously the data, the values are being updated with the new mails. Inside the logic app, if you go to overview and run history, you can see the succeeded message is coming. So whenever a succeeded message comes, that trigger has been happened and the action has performed. I hope this video has helped you understand how to implement end-to-end solution with Azure IoT services. Your support means a lot to us and help us keep creating content like this. So please like this video and hit the subscribe button. Feel free to post your queries in the comment section below. Thank you for watching, and I'll see you in the next video.